Good. Now I need to find how many inset we have in the 30 days. Okay. Okay. This is exponential like that. And the formula connecting this point, and the formula is population at any time is equal the initial population P null e to the kt.
What about
What? I don't understand. Your internet is have issue. Okay, entonces, okay, at the beginning we have 500 inset. Entonces, we have condition. Let me call that thing like a condition 0. We have another extra condition, que es condition 1, in which we have the time, we have the number of the inset, que es 611. We have all things, and this have a condition 2, que in the condition 2 you have the time, que es 30 days, but you don't know the amount of the inset.
Once that just sign up number.
I don't understand, miss. Your internet have problem?
They said that I would see the doctor.
Okay. Yulisa, putting off the microphone, Yulisa.
Marissa Taylor. Mm-hmm. Taylor. Taylor.
Shoot.
Taylor. 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 Yeah, my first name.
Wish.
My last name, Taylor. Yeah.
Okay, let's continue. Now, okay, the condition 0 is using to set out the formula like that. P population at any time is equal 500, P null is 500, e to the kt. Remember, k is the rate of change of the exponential, no? It's the parameter I need to find, and we found using the condition 1. The condition 1, we have whole information that we need to find the k. Okay, we have the time, que es 10, and we have the amount of inset, que es 611. Entonces, in this, at t equal 10 days, we have 611 is the population in this moment. This 500 is the initial, e to the k, que I don't know who is k. No, I don't know. And t is 10. So the only unknown that we have in this problem is k. Okay, so the condition 1 help me to find the k value. Let's do it. This is the exponential equation, no? But it's easy. Look, I divide both sides by 500. We have 611 over 500 equal exponential. I want to change the order here. I put 10k, it's the same because it's multiplication. And you apply a logarithm. Why I apply natural logarithm? The reason is because the base is e, and b suggest me que es natural. So when you apply natural logarithm of 611 over 500, and the other side we have natural logarithm of e to the 10k. Yeah, I know que natural logarithm of the any exponential is equal to the expression. So it's like a natural logarithm and exponential cancel out on those each other. And the answer is 10k. Finally, k 611 over 500 divided by 10 is equal to k. I can put it in a calculator, pero no. Why not? Because this is the partial answer. This is not the final answer. Well, you can put in a calculator and you compute that if you want and storage inside the memory of the calculator. But no. Let's do it another way. Let's do it in the way that you plug in everything and you put the final solution in the calculator. So now I can go to the condition 2. In the condition 2, I have the time, it's 30 days, but I don't know the amount of the inset that we have in this moment. So we come back again to the formula. This is my formula. But in this moment, I have the K value. Okay, the K value is this. Okay? Entonces, population at 30 days is equal 500 times exponential K, K is this, you put it in here, and the exponent part, you put natural logarithm of 611 over 500 divided by 10. Everything this is exponent. Look, this is K, and this is 30. Well, okay, you can, if you want, simplification a little bit, you cancel out this 0 and this 0, because 30 divided by 10 is 3, no? So you put in a calculator something like that. 500 exponential, and exponent you put natural logarithm of 611 division by 500 and multiplication by 3 here and or in the front. Either way. So in our calculator, suppose that this is the display of the calculator. You put 500 times exponential. When you press, remember in our calculator we have two fundamental keys. The key is LOG, the key is LM, and associated with this key we have the exponential associated with this is 10 to the x and e to the x. Okay, we're using both of this and this. Entonces es, you press 500. I want to do in my calculator now. 500 multiplication time exponential is second this. Yeah, I can see in that moment in my calculator something like that. Inside you put LM what? 611 divided by 500. Okay, divided by 611 divided by 500. And you close the parenthesis to indicate we finished the logarithmic part. Close the parenthesis, multiplication 3 or whatever, 3 in the front, multiplication 3, doesn't matter. Multiplication 3. And don't forget to close another parenthesis to indicate que finish the exponential part. So this parenthesis is the end part of this parenthesis open here. And press enter, boom. And we get the answer. Come on, try, guys, and your own calculator. Come on. Everyone working. The calculator is extremely important in this chapter. Come on. Wow, a lot of people. Is Elizabeth, Gabriel, Angelis, Orisa Taylor, Ashley. Okay, this is the answer. Sabrina. Sabrina say that the answer is okay, equal in the calculator 912.39 something 6524. Of course, in the real life, you truncate or round depending. No? In this case, we are talking about inset. So si es inset, have no sense to talking about the decimal, no? Remove that and you focus the amount of inset that we have, well, according to this mathematical model, no? Any question, guy? What part is confusing? Come on. This is a typical problem in which we have the initial condition, condition 0. Entonces es given one intermediate condition, que es condition 1, que allow us to find the K value. And entonces ask me how many insects, how many bacteria we have in the specific time. So you apply the formula 2 times. In the first time, in the condition 1, you find the K, remember, K is a parameter, que the parameter give me the control for the how much, how fast it change the exponential, because suppose exponential, we have the family of the exponential, like that, or like that, or like that, depending the K value. K1, K2, K3, pero no, in this case we have only one K, que es the K specific for our problem. We have 611 insects. Any question? No? Clear or confusing? Okay. This is a typical problem that you can find in Alex, no? Let's see another kind of problem. Que es similar, pero exponential decay. Remember, exponential decay is different. Let me explain the idea, the basic idea, exponential decay. Decay. So decay is growth is increasing. Now this is exponential, look like that. You have P null again at t equals 0. This is the axis of the time. Entonces the formula is P to any time is equal P null e to the kt. Wow, the formula is the same formula. It's the same formula, except que k is negative. When the k is negative, decay. When the k is positive, it's growth. And this problem, talking about physical problem, in which you have radioactive isotope. Entonces, en the radioactive isotope is a chemical element. For example, uranium is radioactive. Entonces, now this is break it down, decompose, and different, and decreasing the amount of substance little by little, and decreasing according to the mathematical exponential decay. Important parameter que is given in this problem is the half-life. Half-life. What means half-life? It's the time in which the substance, at the beginning I suppose que P null, decrease in the half, P divided by 2. And this is the half-life parameter. And normally in this kind of problem is given this parameter, half-life of the uranium, uranium, or carbon 14, or plutonium or something, right? Okay. Let me try to write one problem about this. This is example 2 today. Traces of burned wood. Suppose that we are archaeology and you found traces of the burned wood antique along with ancient stone tools. That we found these tools, antique ancient stone tools, were found to certain approximately 1.5 67% of the original amount of carbon 14. This is a chemical element. At the beginning, I suppose we have 100%. Now, in that moment, we have 1.67. This is radioactive isotope. If I know the half-life of carbon 14 is 5,600 years. Approximately, because it's no exact answer, but it's approximately. When was the tree cut and burn it? Okay, so we are working like archaeology. We discover some wood that belong to the ancient stone tools. And we using the instrument is the analyze the substance. I determine it have this percentage. I want to find the age of these tools. If I know the half-life of the carbon 14 is 5,600 years. Okay, what is the idea? One picture is much better than 1,000 words. Look, this is the time. In this case, the time is measured in years. This is the unit key we are using. At the beginning, t equals 0. We have 100%. 100% of what? Of the carbon 14. But during the time, this is decreasing, exponential decreasing. In one specific time, okay, I don't know, I have no idea, question mark, we have this percentage. It's too small, it's 1.67%. But I know specifically for this chemical element, this carbon 14, they have like a 50% is 5,600 years. Again, we have the three famous conditions. Condition 0 at the beginning, t equals 0. Condition 1 can allow us to find the k value for the exponential, and condition 2. In this case, different to another problem. In another problem, we have the time. Remember, we have 30 days, and we need to find the amount of insect. In this case, different. We have the percentage of the substance. They need to find the time. Okay. Okay, and the formula is the same formula. Is amount, let me copy, amount of substance to any time is equal A null e to the kt. In this case, the amount of substance is not expressed in gram or milligram. No, it's expressed in percent, que es a relative unit. Okay, at the beginning we have 100%. So in our problem, amount of substance to any time is equal 100 e to the kt. Is the initial 100%. Okay, in order to find the k value, we use on the condition 1 always. Allow us to find k. Now remember, k is the rate of change of the exponential. In this case, the exponential, I know que es decreasing, but there are several ways to decreasing. Decreasing faster, decreasing slowly, depending on the case. A K control the decreasing, in this case, because it's decay of the hour exponential. Okay, so now I'm using everything in the condition 1, que es 50%, 50 is equal 100, exponential, K, que I don't know who is K, but I know that the time is 5600. In this exponential equation, the only unknown that we have is K. Okay, you divide by 100, both sides. It's obvious that this is 1/2 when you reduce a lowest term, exponential 5600K. In this case, you apply logarithm. Both natural because it's more countable and when the base is e, ¿no? Entonces I know again this idea que natural logarithm e to the x is equal to x. Okay, it's like this and this does each other. Cancel out. Okay, entonces now in the right hand side we have 5600K. Therefore K is natural logarithm of 1/2 divided by 56. This is my K value. I put in a calculator. You can, of course, you can, but no necessarily. This is a partial answer. This is not the final answer. But by the way, I need notice que logarithm of the number less than 1, because it's 1/2, que es 0.5, is negative. Now the answer that we get after this is negative exponent, because logarithm of the number less than 1 is when the base is e, of course, the standard is negative number. Okay, let's continue. Let's move on to the condition 2. In the condition 2, we have we have 1.67, que is the amount of substance in this moment. So one more time, we're using that formula, but the only new okay, if you want, you put in the calculator. But no. You put 100 here. E to the K. Que K is this value. And T, que is the time que I don't know. Okay. So I need to do something in order to isolate T. You divide both sides by 100. Is equal e to the K. You apply it again, natural logarithm of both sides, natural logarithm of 1.67 over 100 is equal, you know, everything is canceled, entonces KT. Okay, now T is natural logarithm of 1.67 over 100 divided by K. Pero who is K? Logarithm of over 2 divided by 56. And this is time. How you put this in your calculator? Let's do it. This is the display of our calculator. Guys, this is important that you practice. You put in a calculator. Well, you press the key LM. Automatically, when you press the key LM, the calculator, any calculator, open one parenthesis. I suppose que es the first one. So in the parenthesis, I put 1.67 by 100, close the parenthesis. I did the top part. Now division. So in the bottom part, we have one complex division. To say you open the parenthesis. This is extremely important, this parenthesis. And you put LM 1/2, 1 over 2. Multiplication, no, division by 5600. This is this division. And close the parenthesis. Let me try my calculator. 1.67, divided by 100. close the parenthesis, division, open parenthesis. This parenthesis is super important because close everything inside the bottom. Logarithmic of 1/2, 1/2, close the parenthesis to ending the logarithm, division, 5600. And close the last parenthesis to indicate us. You get the answer, right? Okay, come on. Help me with the answer. Everyone working with the calculator, not only Sabrina. Okay, not only Sabrina. Okay. Come on, guys. Everyone bring calculator today. John. Gabriel, you bring calculator. Marta Chivas, left. Wow, why? Anayeli Santos, calculator you have or no? Taylor, Miss Taylor? Ashley? You, I don't know. Okay. Nobody get the answer? I suppose using my common sense, the answer is too big a number, right? Because of the half-life is 5600, so 5600. Okay, the answer is uh-huh, 62 years. Wow. Uh-huh, very well. Excellent. 0.45. John. Very good, very good. Okay, any question? Do you understand very well the problem or no? Okay, so basically, we are discussing two kinds of problems. The problem of the exponential growth and exponential decay. It's similar. It's similar. And the formula is very, very similar. The formula is, for the growth, is population to any time, to any time, to any time, to any time is equal initial P null e to the kt. And this is increasing. This is the time, this is the population. And you need to find the k. Remember, the k is the parameter that controls how fast increasing this exponential. And P null represents the initial. And the decay problem is similar. It's similar. P, no es P, A, porque se llama un susta. It doesn't matter the letter we use, no? It's KT. But in this case, going down, it's decreasing. This is A null, this is time. And K control how fast decreasing in this K. And this K, the only difference in between this guy, K is positive number, and here K is negative number. That is a reason que es decreasing, decay, and this is increasing, growth. Clear or confusing? I promise in the test you see one problem of this, okay? Okay, another problem that we need tempers que is similar, a little bit different, a little bit. Okay, suppose we have one object. And this object have one specific temperature, initial temperature. I call TI, initial. Suppose que 100 Celsius degree. This is the initial temperature. And this is left in one room in which the environment temperature is smaller. Suppose the final temperature is 30 degrees. Okay, so what is the idea? What is the idea? The idea is, this is the time, this is the temperature in that case, the initial at t equals 0. I heat that object is 100. So you left this es obvio que this is a cooling process, so the temperature decreasing. Pero decreasing exponential, no linear like that. No. Exponential to reach 30 degrees is the final temperature. And this is like and so what is the formula for this curve? Well, the formula is temperature to any time is equal temperature final plus parentheses temperature initial minus temperature final e to the kt. This is the formula. This formula is the formula for the cooling process. Newton cooling process formula. So the information that we need is the initial temperature is 100 Celsius degree, the final temperature is the temperature of the room, and we need to find the K. To find the K, we need K exactly the same. We have condition 0. Condition 0 is the initial. We have condition 1, specific intermediate here, condition 1. Condition 1, in which you have the time, supposing the problem 5 minutes, and the temperature is 80. It's obvious it decreases, but a little bit in 5 minutes. They need to find at what time, for example, at what time the temperature is 50 Celsius degree. I have no idea what is the time of this. And this is condition 2. Always in this problem we have 3 conditions. Condition 0 is at t equals 0. Condition 1 is intermediate value that allow me to find the K, always the K here, that K. And by the way, the K is negative number because it's decreasing. But it's different to another because in the K problem, the asymptote is in 0. In cooling process, no. In cooling process, the asymptote is the final temperature. Like that. It's the only difference, but it's similar. Okay, let me copy the idea for the problem. This is the basic idea, but I want to copy the test of the problem. The problem says, problem number 3 is the last one for today, example 3. We have an object. And the object is heated to 100 Celsius degree. This is the case. And is then allowed to cool in the room. Whose temperature is 30 Celsius degree. This is the room temperature. Look, it's obvious that the heat is transferred from the object to the room, and that allow que the object is cooling. If the temperature, so now if the temperature of the object is 80 Celsius degree after 5 minutes. Oh, this is the information for the condition 1. 5 minutes, 80. And this is using to find the K value. Comma, when will is temperature B, 50 Celsius degree. This is the question. Okay. Okay. What formula are you using? That formula. That formula. In our specific problem, what is the final temperature? 30. The temperature to any time is equal 30. Okay, they need the final, look, plus now subtraction initial minus final. So 100 minus 37. A to the KT. This is my formula. But the formula is incomplete now because we don't know what is the value for the K. That to find the value of the K, I'm using the condition 1. The condition 1 say that at 80 Celsius degree, okay, we have 5 minutes. So say 30 plus 70 exponential K, I don't know, and times 5. And using this, you solve for K. Entonces, 80 minus 30, que 50 is equal 70 e to the 5K. This is 50, 70 e to the 5K. Divided by 7 both sides. Cancel out at least one zero is 5 over 7. 5 over 7, sorry. 5 over 7 is equal e to the 5K. Apply logarithm both sides. We have natural logarithm 5 over 7, que by the way, 5 over 7 is the number less than 1. That means que K is negative. Entonces 5K. Remember the natural logarithm and exponential side. Natural logarithm of e to the 5K is equal to 5K because the natural logarithm and exponential cancel out each other. Now, natural logarithm of 5 over 7 is equal to K. Is equal to over 5 is equal to K. I divide by 5 both sides, sorry. And is the final answer? No, this is a partial answer, but we need this partial answer in the moment. And now I need to continue. So we use again one more time the same formula for apply for the condition 2. And the condition 2, the information is given is the temperature. The temperature is 50. So 50 is equal 30 again plus 70 exponential KT. But now I know the K, is that value. Okay, now try to solve for T. You solve for T. When you solve for T, a 50 minus 30, que es 20, is equal 70 exponential KT divided by 7 both sides and cancel out that 0. Of course, 2 over 7 is equal e to the KT. Okay, apply logarithm on both sides. Natural logarithm of 2 over 7 is equal to KT. Now the T, que is exactly I'm looking for, is natural logarithm of 2 over 7 divided by K. This is T. And who is K? This is K. Entonces natural logarithm 2 over 7 divided by K, que K is natural logarithm of 5 over 7 over 5. Okay, how you put this in your calculator? You put in a calculator like that. ln 2 division 7, close the parenthesis, I finish the top part divided by another parenthesis, can close everything in the bottom. It's important, this parenthesis. Natural logarithm of 5 over 7. Multiplication no, division by 5. And close the parenthesis. Let me try. Come on, everyone try in your own calculator, it's super easy. Es natural logarithm 2 over 7 division open parenthesis, another logarithm, 5/7, division, close the parenthesis, sorry, division 5, and close the last parenthesis. Bam, I get the answer. Press enter, and you get the answer. Come on. Exactly, Sabrina. Es 18. 18.61, and I am fine time. Entonces, what is the unit que we are using in that problem for that? Minute. And it's the final answer. End the story. Easy or complicated? This is the kind of problem. In the test, in my test, no. Pero en Alex, yes. In Alex, you need to find this kind of problems. Exponential growth, exponential decay, and temperature. In Alex. Any question that you have in the homework, you let me know. You send me the screenshot. Yeah, immediately I solve for you the problem, no? Yeah, I send the solution. I have here. Maybe another problem. Taking for the Alex. But, you know, when I open my Alex, it's not exactly like your Alex. And every student have different numbers. It's the same problem, the same objective, however, it's different. In this case, the initial temperature is 22 degrees. The room temperature, que es the final, is 10 degrees. A typical cooling process, no? Decreasing the temperature. And we have one intermediate condition, que es the condition 1, que we're using always to, que is the temperature. Wait a second. (22, 18, 10). Oh, no, it's easy because the K in Alice is given. Okay, in K, no condition 1, no. In Alice, maybe it's easier. It's negative. For the cooling process, temperature to any time is equal temperature final plus parenthesis temperature initial minus temperature final exponential KT. But K is given. So now temperature to any time, and now I write the specific. This is general formula. A specific our problem is 10. And you subtract it. Initial minus final, que es 22 minus 10 is 12. E to the minus 0.03 T. And this is the formula, my specific formula. And they want to find, for example, at what time the temperature is intermediate value here. At what time the temperature is equal Celsius degree. Okay. So you plug in here 18. 18 is equal to 10 plus 12 exponential minus 0.03 T. And you solve for T. Okay, this is algebra. 18 minus 10 is 8 is equal to 12 exponential minus 0.03 T divided by 12 both sides. 8 to third is equal to exponential minus 0.03 T. Entonces, this is an important moment in which you apply the logarithmic, both sides. Logarithm, 2/3 is equal, and logarithm of this is minus 0.03. You see, it's magically logarithm exponential each other. And stay only this point part, it is. Finally, logarithm of 2/3 divided by negative 0.03 is equal to. Wow, something is weird because, wow, the time is never is negative. It's 3 equal to. The time never is negative, but the problem is that natural logarithm of 2/3, que is a number less than 1, is negative. And negative divided by negative positive. Okay? The calculator, how you put in the calculator? You put in the calculator like that. Natural logarithm 2/3 division, parenthesis, negative 0.03. Be careful with the negative, because in our calculator we have two kinds of negative. Yes, negative subtraction and negative of value when it's negative. Normally, in my calculator, the value negative is white color. Entonces es obvio que es negative, no subtraction, because subtraction is in between two quantities. You have only one. This is the answer. Sabrina said the answer is 13.51. 5. Exactly. The answer que Sabrina get and John is 13.5. And the Alex specification, how many days to get the correct answer? They want you round only one decimal place, entonces 13.5 minutes. Okay. Entonces I suppose que we stop today here. We stop. No more today. And next week, slow down. We start doing the review package for the test. Okay, guys? Okay. Everything is clear so far? Clear, right? Good.